Hello, my name is George from Man and Machine, and today I'm going to be showing you what's new in Inventor HSM 2016. So the first thing I'm going to be talking about is the turning features that have been added into Inventor HSM. You can see at the top there's a new tab included with the turning features. So we've got profiling, grooving, facing, parting, threading, single groove, chamfer and stock transfer. To start off, we'll be working on this little part. It's just a basic part where we're going to be using a facing toolpath, profiling toolpath, a grooving toolpath, and finally we'll part it off. A bit later on in the webinar, we'll go on to use a lot more of the turning features on this more complex part. So we'll be using the chamfer toolpath, we'll be using threading, we'll be using a 2D contour because this is a mill turn operation. We're using drilling and tapping, and obviously we'll part it off again. As well as the turning features, I'll go through a few little tips and tricks you can use just to finish off the edges of fillets. I'll go through engraving, because these are a few questions that we've been having before. How to engrave, how to finish off fillets, and how to do a slot toolpath, because a slot is different to a 2D pocket. So we'll come on to that a bit later on. And I'll show you a few examples of turning features. So we've got just a little castle here, which is using mill turn. Okay, so we'll start off, we'll just work on this part. I'll run a simulation first to show you what we should end up with by the end of the creation. So we're going to face off to start. And then we'll run a profiling toolpath, speed it up a bit. We'll run grooving, and then we'll part it off. So this is the finishing part that we should end up with. So we'll go ahead and we'll close the simulation, and we'll minimize this setup, and we'll start from scratch. So we'll create a new setup, and you'll notice that there's a new option been added in here inside the operation type called turning or mill turn, which we'll select for now, and we'll just set the Z-axis to be about this circular here, and we'll set the origin to the stock front. So we can go into the stock section and we can change the mode now to fixed size cylinders, tubes, or from a solid. For this demonstration we use a relative size cylinder, and we'll say there's a radial offset of 0 mil. So we've got some stock on there which is basically cut to the outer diameter here. And we'll just give it a name, we'll just keep it as 1001 for now, and press OK. And we've got the setup in. So the first operation we're going to do is going to do a facing toolpath. So we'll just click face here. And we'll just choose a tool, same as we would if we were milling. We'll go into tool by type. But instead we'll choose any turning tool. And we can just choose one of many tools that are in here. If you want, you can create a new tool by just either making a library or going into the part you're doing now. So we're using the turning part. And we'll choose new turn tool, and you can see there's a little preview of the tool that we're making here. We can head over to insert, and we can define a lot of different inserts inside here. We can set the size of the inserts, we can set the cross sections which are for the inserts as well, and the tolerances, the relief angles, and obviously the thicknesses. You can also set different sizes of holders. We can take the holder off, we can set where it's clamped, we can set if it's left hand, neutral, or right hand, and we can set all the widths and the heights of the holder. For now, I'll just use the default ones that we've got in here, and I'll just select this one at the top, press select, and we've got the tool in here now. So we'll go over to the confinement section. We don't need to confine it because we're just going to be facing the part off. So we'll just leave all the other tabs now. We'll keep lead in and lead out and press OK. And now we'll run a simulation just to show you the facing toolpath. You can see the tool's just going a straight line down to face off the part to the model front. The next option we want to create is the profiling toolpath. So we'll just choose profile. And we'll use the same tool for this. So it's already selected from the previous operation. And we'll untick allow grooving. Obviously we're using the profiling tool for now, so we'll untick allow grooving. We want it to go from the front to back, and it's going to be outside profiling. You can use this option for inside profiling, and you can change the orientation of the tool if need be. So we'll just set that to 0 now, so it's a straight tool. We can set the spindle speed and the lead-in feed rates and the cut-in feed rates here as well. But I'll just leave them for default as this is only a demonstration. And we'll go into the next area. We can leave confinement, but we'll tick rest machining as we've already faced up the part and we don't want it to go over there. We'll head over to the passes tab. We'll untick finishing passes for now. And we'll keep the roughing passes. Go to linking, and we'll keep in lead in and lead out moves. Just press OK. And again, we'll run a full simulation, and we'll see the part be faced off. And now I'll speed it up a little bit, it can take a while, and we'll see the part being profiled now. The collision detection worked exactly the same as in milling, so you'd see at the bottom a red icon if there was a collision, and we can set it to stop on collision if needed. But there's no collisions in this, it's just a simple part. So we'll close this simulation down, and we'll go ahead and we'll create a grooving toolpath now. So we'll just choose groove, and it's automatically selected a grooving tool for us. But we'll go into the library and we can just select another one if need be, but we will just use the one that's been selected and press select. And we'll go to the geometry tab, sir, and we'll choose confinement, and we'll say confine within this area. This is only going to groove within this area that has been selected now. And I'll just press OK. And you'll see the grooving toolpath been added in. So we can run another simulation on that. And we'll jump to the grooving operation. You see that the grooving has been done. We'll close that up. So now the final thing on this part is to part it off. So we'll just choose part. We'll keep the same grooving tool and press OK. So now we've parted it. So the whole job will be finished now, and we'll run a simulation on the whole part. I'll just jump across the sections. So jump to the grooving. See grooving is done, and then you'll see the final toolpath parts off. And that's this file finished. We've gone through the facing toolpath, profiling, the grooving, and parting to finish the part off. So we'll leave this part now and we'll go on to a more complicated one. What we've got here, we're going to use quite a few more of the strategies. We're going to use, like I said before, we're going to use 2D profiling, we're going to use drilling, tapping, threading. We're going to use a chamfer, so we can add a chamfer on even if it hasn't been drawn. And then we're going to part off again. So I'll run a simulation to show you what we should end up with. So I'll play the simulation, just face it off. Now we're going to be profiling. I'll speed it up a little bit. So it's going to go through and just profile the whole part first. And then it will come and groove the centre part which I've selected. And then after this it will groove the rear of the part. And then it will come and groove the front of the part. So after that it puts a little chamfer on. And it threads the part. It does a 2D contour, drilling, tapping, and then parts off. So we should end up with this as our finished part. It'll be quite a complex file if you're going to program this manually, but this will show you how easy the turning features are in Inventor HZ. So we'll close down the simulation, and we'll minimize the setup, and again we'll just work through it from scratch. So we'll create a new setup. We'll change the operation type to turning or mill turn. We'll choose the Z-axis, and we'll make sure it's from stock front, We'll keep the Z-axis on this side. And we'll come over to the stock. And it's a fixed size cylinder now, which is a bit too big for what we're doing. We'll say it's a 45mm diameter tube, or cylinder, sorry. And we'll give it a name, so we'll put it 1002 this time. And press OK. And we can say goodbye. Okay, so the first operation we want to do again is face off. So we'll choose face. And we'll choose, again, we'll choose a grooving tool, a profiling tool, and press select. And then just press OK. We'll keep the default speed and speeds, what I said. And we've got the facing toolpath done, so we'll run a quick simulation just to check there's no collisions. And that's fine. So we'll close that off. And now we'll go over and we'll choose to profile the part. So we'll use the same tool again. Disable allow grooving. And we'll untick finishing passes for now. And we'll press OK. So now we've got the profiling operation done, we can run simulation again and check for collisions. And you see there's no collisions at the moment. None are showing up at the bottom. So that's fine. Now the next operation we're going to do, again, is a grooving operation. So we'll just choose groove. And we'll confine it this time between this area and this area. And press OK. And then we'll create a derived operation. So this is going to keep all the speeds in the selected tool. And all we're going to do is just change the confinement area. So I want to now confine it from the front here to here. And press OK. And then we'll create another derived operation. And we'll confine it from here to here. And press OK. And that's going to groove off the back. So we'll run a simulation now and just check see if there's any collisions, which we can see there's a few here. We'll run it through and see why they're colliding a bit later on. You can see it's grooving. And looks like it's on the finishing pass it's colliding. So I'll turn off finishing passes for the grooving tool just for these first two operations. So we'll come here and we'll untick finishing passes. And we'll do the same on this one. I'll untick finishing passes. And then we can check the simulation for collisions. And you can see now there are no collisions. So we'll close down the simulation. And the next thing we want to do is add a chamfer onto this edge here. So we just expand the turning tab. We choose chamfer. And we'll choose our profiling tool that we used first. So it's outside chamfering what we're doing. We can choose it to do inside, but for now we'll just choose outside chamfering. And we'll choose the outer edge to chamfer. So you can see the preview of the toolpath is adding a chamfer which goes through the model, so the chamfer doesn't need to be modelled. You can just do it on any edge that's selected. And you can set the chamfer width, and you can set the chamfer extensions and the angle all in this passes tab. So I'll just set this as a 45 degree 1mm by 1mm chamfer. And we'll leave in everything else. And press OK. And a good way to see the chamfer, because when you run a simulation the model is always visible. So if you cut through the model you'll see the model behind, which obviously the chamfer is going to be cutting through. So a nice way to see the simulation is to switch over to the model tree and right click on solid bodies and just hide the solid bodies. Then switch back to the cam tree and run a simulation. This will give us a better visual simulation, as we can see the chamfer and we won't see the model sticking out from the stock. So it's running the grooving passes, and then it comes through and it will add a chamfer on. And as you can see, the chamfer's been added on with the profiling tool very easily. So the chamfers aren't even they don't need to be modelled. You can just select them, and it will put the chamfer on for you. So we'll close down the simulation, and we'll just make the solid bodies visible again. And we'll head back to the CAM tree, and we'll make a 2D contour now. So we're just going to cut around the edge of this part. So we'll choose 2D contour, standard milling operation, and we'll choose the 6mm flat. And we'll select top contour, and I want it to come down to the bottom height is here. Just going to mill down to the bottom. I can set it to go to the bottom there, and then press OK. And you'll see the 2D contour is added on like so. So we can do that with all milling operations, as this is a mill turn program. You can choose any mill turn operator or any milling operations, and they're all accepted inside the turning. So another one we're going to choose is drilling. So we'll just choose drill, and we'll choose a 4.5mm drill, and we'll select this whole face, and then choose select same diameter. So now we'll just press OK. We'll leave the standard drilling cycle, just drill in and wrap it out. We could change this to pecking if we wanted, but for now we'll just leave the standard one. And we'll right click, create derived operation, drilling, drill, and we'll change the tool to a tap. So we'll use a 5mm right tap. And we'll switch over to cycle, change the cycle type to right tapping, and press OK. And now we've got drilled holes and tapped holes. Okay, so the next thing we'll go through is we'll put a thread using the turning feature called thread on this front face here. So we'll just choose thread, and it's already selected a default threading tool, which we'll keep for now. It's set as outside threading, which is fine, again, because we're doing outside threading. And we'll choose the thread faces here. And now I want to set a backside offset. As you can see, it's going to go into the model. So we'll set the backside offset as, let's say, -2mm, just to bring the thread a bit further back. And you can see the little angle that's bringing out on the thread. This is going to fade the thread. So if you don't want this angle there, you can just untick that and it will come straight out. So it's a right-handed thread. We can set the thread depth and the thread pitch in here. I'll leave the default ones for now and just press OK. First off, I'll just show you the number of step downs, so you can see here the thread's going to be done 5 times. You can lower that down in here, so say 2, and it will just thread it twice. And just press OK, and that has been created. So what we'll do is we'll switch off the model visibility again, and we'll run a full simulation on this setup. So it's facing the part, it's profiling, and it comes through, and it will do the grooving, and it will groove the front, and it will groove the back, and it will put a chamfer on, it will drill the holes, then it taps the holes, and it threads the part, like so. So now we've got a nice, neat little part there. The last thing we need to do is just part it off. So I'll just choose setup, and we'll choose part, and just press OK. Obviously you can set the speeds and feeds in each section. All here, cutting feed rates, spindle speeds, the lead in feed rates for everyone, but as it's a demonstration, I'll just leave the default speeds and feeds. And I'll save that part. So now the simulation, I'll just jump through it. It's parted it off, and you'll see that at the end. So that'll be our finished part. Create the stock. Okay, so we'll close this down. I'll show you can change the thread if needed. Again, simple to change the thread. you can just change the depth, say 1 mil, change the pitch to 1 mil. Okay. We're on a simulation. It's going to be a crash because I'm not simulating the whole part. I'm just going to show you that the thread changes with that. Okay, so we'll close down that simulation and we'll head on to another part now. And now we're going to be looking at the castle file I've created. We're just going to be looking at how I've created the milling operations on the front mainly. Just want to show you how I've made them extend, because this is quite a good feature in HSM as well. So I'll just go ahead and I'll edit the 2D pocket to show you what I've done with the selection. As you can see, I've just selected the edges of each one of these little slots in the top, and I've enabled stock contours for the toolpath to be extended to the limits of the stock. So this is going to drive the tool a lot further than the pocket, rather than just selecting the bottom face, which would leave a little radius on each corner. This is a way that you can use basically to clear out all the radiuses that would be left. It's quite easy and it's a quick strategy to do. So you just enable stock contours and you just select the bottom edges like so, and press OK. And you see the toolpaths generated there. So I've run a simulation on this part and you can just see how the turning and the milling strategies work together. Let's press simulate and start it. You can see it facing it. Then it will do a profiling toolpath with a different tool. You can see it's a different tool that we've been using before. Let's speed up the simulation a bit. And you can see the grooving tool. I've got a finishing pass with this grooving tool as well. Obviously this can be disabled if needed. And then there's the milling operation at the end. And you can see the extended pocket is going to the limits of the stock. And then just parting it off to finish. So that's the finished part. Again, it's the same strategies that we've used before. And it includes just the basic 2D pocket milling on the front as well. So we'll close off the simulation now and we'll head on to the next example file that I want to show you. I just want to show you a few of the good little features which are in HSM which you don't necessarily use all the time. So I want to show you how to create a pattern. So the pattern is just using a single toolpath which I've created here and mirroring it about a plane. So I've just selected a plane from the model tree, which I'll show you how to do in a moment, and it mirrors it across, so to the next hole. And you can drag as many things into this pattern as you want. So I've got the radial toolpath just dragged in there, and that will mirror the radial path as well. It doesn't show, when you click the pattern, it won't show the radial, it will just show the first one, but if we run a simulation, you'll see that it does mirror both across, and it orders them by tool as well, so it goes through as a radial toolpath now. Okay, so we'll close down the simulation and I'll just show you how through the creation of that. So we'll delete the pattern and I'll just create a 2D pocket. We'll just select a 6mm flat tool and we'll select the bottom of the pocket of the machine. Just press OK. Let the toolpath generate, and then I want to click pattern. And for this, I'll use a mirror pattern. And for the mirror plane, I can just switch back to the model tree, expand the origin, and choose the correct plane, so the YZ plane. And you can see the preview, it mirrors straight across there. And we'll switch back to the cam tree and just press OK, and you can see it's made the pattern folder there. And I'll run a simulation and it creates both toolpaths. And then press close. Now I'll go and I'll create a radial toolpath just to show you a nice way of finishing off the edges of filleted edges. So we'll choose under the 3D milling section, we'll choose radial, and we'll select a 6mm ball for this. And we'll go to Geometry tab. So the center point is the center point of the radial toolpath. So we'll just choose the center point of this square, which I've projected to here, like so. And then we'll set the machining boundary to selection, and we'll say we only want the radial toolpath to work within this area, and we'll keep the additional offset of 0, and I'll show you what that does in a moment. And just press OK, and you can see the radial toolpath being created. It doesn't extend past this, past the top and the bottom. Obviously it does in the linking, but so to give a better finish, we want the toolpath to extend past the limits of what we selected. So we'll edit this radial toolpath, come back into the Geometry tab, and this feature allows us to extend the toolpath past the area that we've selected. So we'll just add it up to 5mm, that's OK, and you can see it extends past by 5mm both sides. And we can see it's dropping down, so I'll show you another feature now on how to stop the tool. Well, we can limit the depth the tool goes to, so it's not going to drop right down to the bottom of the part. This is obviously a wasted move because it's all been pocketed out already. So we'll just edit it, go to the Heights tab, we'll say the bottom height, selection, and select that as the bottom height, and we'll just put an offset of say -2mm in there, so the tool could drop down to -2 below this line here, and we'll press OK. And you can see that's been generated. So we'll simulate that pattern. Just do quickly the pockets, and then you can see the radial toolpath. It just spirals around, going in and out about this point that I've selected here. So the centre of the square, and you can see the centre points here. So this is a good way to finish off radiuses or fillets that you put on the on your file. It's a lot better than the parallel strategy that a lot of software uses. It would be good, obviously, the parallel on one edge, but then when you come to the next edge, it's just going to fall straight off and miss the radius that you've got on there. So this is a very good strategy to clear out these fillets. Okay, we'll press close and I'll stop that simulation. And now I'll show you the tracing strategy, how it can be used for engraving. So we'll minimize that and I'll delete the tracing strategy, it's already been created. And we'll just go through and we'll create another one. So I'll just save the part, 2D milling, and trace. And for this, I'll use a 1mm ball. And now I want to select the geometry. And rather than using the traditional way of selecting each line, we can do it a lot easier way. And to do this, we've got it selected. So similar to how we selected in the pattern folder, we can switch back to the model tree, and we can just select a full sketch. So we can select sketch 7, which has got all the writing on, and then just go straight back into the cam tree. So it's a very good feature and a very good way of selecting the sketches. So we'll just go over to the Passes tab, and we can set an axial offset of -1mm. So this is going to drive the tool in -1mm from the surface, because this sketch is drawn on the surface. And just press OK. And we can see the heights are a bit wrong. We don't want the tool to lift up that high every time. The part's been faced, so it'll be very accurate. So we'll just edit that tracing strategy. And then we can change the feed height, the retract height, and the clearance height all in here. So we'll set the feed height to 1mm, retract height to work from the feed height, we'll say 0.5mm higher, and then the clearance height we'll just set to 5mm from the retract height. And you can see the lines are a lot lower now. Okay, so we'll run a simulation on the trace, and you can see what it's doing. You can see it's just driving the centre of the tool along the lines, and it's driving that 1mm into the material. So that's where the axial offset feature comes in. Okay, so that's how you do engraving in Inventor HSM. just using the 2D milling and trace option here. Now I'll show you the slotting option. So we can do 2D slot. And for this, we'll just choose a 2.5mm flat, and we'll just select the bottom face of the slot and just press OK. So you can see what the slot does. It is just going to do a straight line down the centre of a slot. It won't try and clear excess material like the pocket and the adaptive strategies do. It will just do a straight line along the middle. So you will be cutting a 2.5mm slot with a 2.5mm tool, as I am in this. The 2D adaptive and 2D pocket features will fail trying to choose the same size tool, because they are like pocketing features, they're not slotting features. So for that you'll have to use this 2D slot. Okay, so I'll run a simulation on that, and we'll just drop them out of the pattern. So let's run a simulation. And you can see the slot just does the straight line. So I'll close that off. I'll delete the other slot I've got. And then you can just reorder quite easily by just clicking, dragging and dropping in the order you want the part. So I'll save that, and now I'll go through the post-process tab. So I'll just choose the setup, choose post-process, and now I'll just choose the generic house post, which is here, and just press post. Let's save. And you'll see the NC editor window opens. So this Inventor HSM edit program is included with Inventor HSM. It's a separate application which is just used for editing NC files. You can preview NC files, as you can see on the window here. And it's just a quick text editor which gives you a nice visual appearance of the G-code. You can see all the line numbers are coloured. You can customise the colouring if you want. And it allows for quick access of lines. So let's say I want to edit the G0 line here. I'll just double click, and it takes you straight through to that line of code. So it jumps to line 335 in this case. And you can just move on and just jump to any line you want by just double clicking the part that you want to move to. And you see it jumps through 30,376 lines in milliseconds just after a double click. So it's a very easy way to access the code and to look through if you need to make any manual edits, or if you want to make any manual edits. It's a very good program. You can run the simulation just by pressing the play button, and obviously you can slow it down with the slider similar to HSM, and you can watch the movements the tool is going to be making. And you'll notice on the left hand side here that the code is live feed, so while the simulation is running, it's showing you the exact line of code which generates that movement. So this should simulate what the actual machine is going to be doing. This is just a free access simulation, and it just uses a generic tool on there, as all the lines are obviously just the center lines of the tool. You can pop over to the NC functions tab here, and we'll scroll to the top so you can see. And you'll notice there's quite a few things you can do in here. You can adjust the feed rate, the spindle speed, you can rotate the toolpath. It's just got a little calculator there. And you've also got toolpath statistics. So this just tells you the machining time, the cutting time, the lengths, the dwell time, and you can edit the rapid rates and the tool change times here to make it more accurate. I'll just close that down, and I'll show you the adjusting the feed rate. So you can see here that the feed rate is a meter a minute. So I'll just click adjust feed rate. This adjusts the whole file. So I'll just say I want to adjust the whole file by 200%. So let's change the percentage here to 200. I press OK. And you'll notice the feed rate changes here to 2 meters. And you'll notice that throughout the file. So I'll just search for feed rate. So there it's been doubled. All the way through the file, the feed rates have changed. So you can do this with the spindle speed as well. I'll just go back to the top of the file, and we'll just click adjust spindle speed, and we can do it in percentages or we can set a maximum spindle speed value. So let's say our spindle doesn't go any higher than 500 RPM. So we'll just head to 500, and you should see the spindle speed here, so S1000, which is 1000 RPM, should change to 500, as it shouldn't exceed 500 what I entered here. So I'll press OK, and you'll notice the spindle speed will never exceed 500 in the file now. This is a good way to set a maximum and a minimum spindle speed in the file. So I'll adjust the spindle speed again, say a maximum value of 5000 and a minimum value of 4000. Spindle speed goes to 4000. Again, this is an easy way of editing the files. It's got support for hide and hind, just generic G codes as well, turn-in files, and just the standard Autodesk post files. You can also add text files and use the text editor if you want, but it's mainly for the milling, the turn-in, and hide and hind files. I'll just close off the back block window, and you can see the NC Assistant tab on the left, and the Cycles and Macros tab here. So this allows us to enter in a line of code really easy. So we'll just, let's say we want to enter a line of code just after the spindle speed's turned on. Actually, we'll do it after the G17 move. We'll go press enter, and you'll see the line numbering is automatically changed. So it's automatically entered a new line number in for us. Press enter again, it will add a new line number. We'll just delete that one out. And let's say we want to add a rapid move in here. So we'll just double click here, the G00, and we'll enter the X, Y, and Z coordinate that we want. So we'll just enter 500, 520. We'll press OK. And you can see that line's added in really easily. And this works with all the G codes you've got down the left. You've got G codes and M codes, which are customizable as well. Obviously, all machines use different M codes and G codes, so these can be customizable. And let's just say we want to add in a linear move or clockwise arc move. We can just say the X, Y, and Z coordinate of the arc as well, and then the radius. So we'll say 20, 20, 20, and the arc of 10. Add the move in for us. Okay, so I'll delete those lines out and just save the file. And another thing that is built into this Inventor HSM edit program is a DNC. So this is a drip feed or direct numerical control, and this can be easily set up by just going into this tabs here. So this is used to drip feed the DNC file to older machines which don't have storage which can store, say, more than 1,000 lines. You can just use a DNC and set up the drip feed control direct to the machine, so you can run larger files there. As you know, some machines don't have a large hard drive, and for a file with 30,000 lines like this one, might be hard to store on an old, like, 1980s machine. So this is where DNC would be useful. So that's it for the Inventor HSM edit program. So I'll just close this down. And this takes us back to our normal part. So I've gone through some of the turning strategies that have been added into Inventor HSM. We've got the profiling, the facing, and the grooving. There's a lot of turning strategies. They're really easy to use, and I like the features in here. I've showed you some of the 3D strategies, just showed you the radial 3D strategy. There are a lot of other 3D milling strategies in here, which I can show you if requested, and these are roughing strategies here, adapted in pocket, and then there's a lot of other, like scallop, spiral, morphed spiral. There's a lot, and you can see the little illustration there which pops up. So that brings us to the end of the Inventor HSM What's New webinar. Thank you for watching, and if anyone's got any comments, please write them in the comment box, or any questions, please write them there as well, and I'll try and answer them for you now. Thank you.